Hello, my name is 𝘮-An from Professor Qiu Jingwen's lab. My thesis topic is Synthesis and Reactivity Study of 𝘮-Terphenyl substituted borinium cation. Boron compounds are intrinsically electron deficient. To even enhance their Lewis acidity, cationic boron species are popularly explored. With only 4 valence electrons, di-coordinated boriniums are highly reactive and their synthesis can be challenging. As heteroatom substituted boriniums usually possess significant pi bonding, they are more like heteroallenes, and their further reactivity studies are rare. All carbon substituted boriniums, on the other hand, were not successfully synthesized until 2014, with Shoji's dimethylborinium being the only example of diaryl borinium. Almost all its reactions resulted in the cleavage of boron-carbon bond. Another method to completely modify the electronic property of boron compound is to introduce unpure electron. 5 valence electron boreal radicals have both unpure electron and empty orbital that can bind substrates, and it is calculated that such species can activate dinitrogen with room temperature accessible barrier. However, the pursuit of neutral disubstituted boreal radical is not achieved yet. We envision that this radical can be prepared from a single electron reduction of boriniums with bulky substituents to prevent dimerization. And to further investigate the reactivity of borinium cation, unsymmetrically substituted species can also give us insights on its selectivity. Therefore, in our molecular design, a bulky 𝘮-terphenyl ligand, DMP, was combined with Shoji's borinium. The targeted DMP methylborinium was synthesized through sequential ligand substitution and chloride abstraction, with its structure confirmed by X-ray crystallography. The attempt of generating its corresponding boreal radical resulted in the activation of the ligand. The flanking methyl ring of DMP group is in the vicinity of boreal radical, and the formation of boron-carbon bond transferred the unpure electron to a less sterically protected site. The following dimerization quenched the spin. One of the diastereomer structure was also confirmed by single crystal XRD. Computational analysis revealed that the dearomatization step occurred with a barrier of roughly 21 kcmol, while only a low-intensity featureless EPR signal was observed in low-temperature reduction reaction. Meanwhile, the metathesis reaction between DMP methylborinium and triacylsilane resulted in the cleavage of methyl group to afford dihydroboron dimer and silicium cation. Very similarly, the reaction between DMP methylborinium and terbital chloride yielded dichloroboron and protonated mesitylene. We hypothesized that those superacids were resulted from hydrido and chloroborinium intermediates. Computational studies suggested that not only DMP group stabilized the chloroborinium intermediate through cation-pi interaction, but its steric bulkiness also raised the barrier for protonation at the boron DMP site. In conclusion, we synthesized the unsymmetrical DMP methylborinium. The reduction reaction yielded dearomatization dimerization product. Additionally, the metathesis reaction with triacylsilane terbital chloride cleaved the methyl substituent, and it was proposed that hydrido and chloroborinium were formed as the intermediates. In the future, we will design other ligands to keep trying to synthesize the substituted boreal radical and explore more reactivity about DMP methylborinium. I want to thank everyone that have helped me with this project, and I want to thank you for watching.